Welcome back, everybody. It is officially time for our wrap up.
We're
This is
back.
your time with Milton to show what you've done today. What have you created? We want to see these amazing vehicles. I saw in the chat during our Q&A that somebody's vehicle was too heavy, so I hope they got that worked out in the second breakout
Okay,
room.
okay, okay.
And I can't wait to see. So please do not be shy. Turn on your cameras. I'm going to pass it off to Milton to start our wrap up.
Oh man, thank you so much, Monica. This is so exciting. Welcome back to EV Day. And I'm highlighting this vehicle and I'm highlighting GM because right after we finish, showing off these amazing electric vehicles that you all are going to display, you're going to be, we're honored to have the great Tel Magruder. I mean, I'll make more excited about hearing her speak than a lot of presenters, awesome presenters that we brought in because she just brings a unique perspective to General Motors, to electric vehicles, and even to diversity. So it's exciting. This is our wrap up. Can't wait to see some of the vehicles you all have developed. But let's do this first. You all just wrapped up lunch. See, I'm nice. See, Monica, I'm going to give them a couple more minutes to get their vehicles ready. We're going to do that for you because we want them to be ready to go, right? We want to see them operating as soon as you turn your screen. So hey, hit this Slido poll for me real quick. What is your go-to lunch? You just wrapped up lunch. You had a little lunch and play, lunch and develop. What's your go-to lunch? What is your go-to lunch? Let's see what they're putting in the chat as well as getting this Slido. What is your go-to lunch?
And do not be shy. You can type in chat. Your teachers can hop into the chat or somebody let us know. Turkey sandwich.
Oh, that's good. That's good. I'm loving it. I wonder, Megan, what's your go-to lunch? Like what if you had to eat one lunch every day for a week, what would it be?
I love pizza. I'm from New York, so I got a soft spot for pizza.
New York style pizza, the kind that you can kind of fold and wrap. Oh yeah.
I love Washington, D.C., but they're just not cutting it with the pizza.
Definitely not. There you are. Just gotta say
we just ordered pizza. We just ordered our pizza for lunch.
Thanks for sharing, Camille. Yes, more
Catholic in Staten Island. They're having some good pizza, no doubt about it.
Slice. I gotta say this. Megan is great people to know, so you definitely want to stay in contact with her. Good old peanut butter and jelly sandwiches. Oh, wings. Just any Mexican food, I'm down with you. Orange chicken, pizza's coming in strong. Homemade something from Granny. Anything from Granny, homemade. Let's do it.
Sushi. I don't know if you saw Louisiana said no food is better than their food. That's in the chat.
Yeah. Oh yeah. Hey, Constance, we gotta go on a tour. I think we need to take ET on the road just so we can try out some different food. Jerk chicken and rice. Maybe that's Louisiana. Wingstop. All right, that's great. That's great. All right, let me let's do another one. Oh, is this you and I, Constance? I love Giordano's pizza. Oh my God, deep dish. And no, this isn't. This is Monica.
That's my paella. Yes, that's one I actually made. Yes.
Isn't it beautiful? Monica's great people to know. She could freeze it and send it to you. All right, next. Hey, where are you all? I love Giordano's too. Northbrook High School. Let's go. What phase are you in this process? Are you still researching? Are you designing? Are you assembling, testing? Trust this. Wherever you are, oh, look at that coming in strong with some assembly and testing. Wherever you are, we just want to see it. Even if it's not moving yet, that's fine. Look at these teams working hard. We just want to see it. So we got testing going, we got assembly. That's good. Some folks are still assembling. That's all right. Show us the assembly. We got some great engineers on here. Well, maybe we can rework this thing in real time. Oh, that's what I like to see. A little more testing coming in. All right. That's good. Hey, I'm stalling for you. I'm trying to do my part. All right. What did you like the most about this lab? Last question. And then we're ready to go. What did you enjoy the most? I have so many things I enjoy, but I'd love to hear from you all. Okay, cool. Someone said testing. I love testing. Hey, Catholic high school, more Catholic. Can't wait to see what you did. Trial and error. Hey, you're speaking to all the items in the engineering design process. You're killing it. You did? You enjoyed my talk. That was nice. I appreciate it. I knew something about you all. I just knew it. Good. Test running. Oh, building, yeah. Teamwork, camaraderie, right? Working together as a team. Can't do that. I think it's cool. Being creative with my bros. Okay. Northbrook said a little collab. Nice. Trial and error testing. All coming in strong. Monica, I think we're cooking in hot grease now. I think it's time to get
I
this
think
thing
it's
going, right, Constance? Let's
I
do
think
this,
so
Jillian.
too. I actually see, I don't know, in Portillo, Giselle's camera, I see a car there, but I don't see a student there. So let's
Hey.
see if people can raise their hands on Zoom and I will spotlight your group and they can talk to us about their car. Do not be shy. Oh, I see a hand up. Preston is ready. All right.
Oh, let me
Milton, if you
stop
could stop
sharing.
sharing. Thanks. All right. Preston, here we go, Preston. You got
Ooh.
to unmute, Preston.
Oh, look at that. Ooh.
Unlock myself.
We're
There we go.
starting
Now
off
we can hear
strong.
you.
Okay, here we go. Show it off, talk about it.
Hi, this was $39. We did 2 propellers, which goes really fast. The 2 batteries in front.
Cooking,
He did a little
cooking.
winky face.
Oh man.
Ah.
Oh, look at the aesthetic appeal. Very
You want
nice.
to put it, run it, we'll watch you go.
Yeah. Let's run. Oh, if this
Wait, we
works,
gotta pull it back a little bit.
if this works off the jump, first one, man, that's outstanding.
That
Yeah,
would
you
be
gotta close the circuit. Gotta close the circuit.
Wait, she's turning it on.
Yeah. Oh, what? Do they
Oh,
have a
no.
switch? Did they implement a switch?
Got 1 second on.
Okay.
What
I
happened?
just got 2 batteries, so take your time. Take your time.
Make sure your batteries are clicked in.
Look at the anticipation of the audience. Can you see it? Look at everyone's face. It's almost like a rocket's gonna get
There we
launched.
go.
Oh, look at those
Oh, I
fans
see it
moving.
spinning.
There
Oh,
may be just a little short somewhere. Oh, it's going now.
Oh,
oh.
man.
Hey,
To the room,
we have
lost the
time.
fan.
We have time.
Yes.
We're coming back. We're
coming
coming back.
back to
No,
you,
troubleshoot
Preston.
it. That's engineering. Troubleshoot. Fix it. We're coming right back
Slight
to you.
malfunction on the walk from the table. They're gonna get it fixed.
All
Let's
right.
do it. All
We're
right.
gonna go
Hey.
to
Oh,
Northbrook High School had their hand up next. Northbrook, can you unmute and show us what you got? You guys are ready.
Hey, Northbrook. They
Oh,
look
here we
serious.
go.
Like,
Oh,
man,
there.
they're not playing games. Oh, look at that sleek design. Ooh, do you see the pulley? I'm so proud of you.
It's a really simple design though, but it goes really
Yeah.
fast.
Oh, let's do it.
Can we see it?
We gotta have a race. I should have brought my car. Look at this. We got Constance. Here's the ET competition. See, it all worked out. Look at it. We're done. Nice.
All right.
Oh, I love the distance. We got a measure the foot. Oh, that
Ooh,
is fast.
and it's really
Whoa.
pretty straight.
Sheesh. How did you
Very
do
nice.
that in just an hour?
Debbie?
How did you all get that done in an hour? That's amazing.
Well, it was pretty easy once you knew how you had to build in order to go faster. So it's a simple design because if you add more things, it could get really heavy and it's going to slow down.
Wow. Did you all hear that? Simplicity. Man, you really thought this thing through. What's your plans after high school? I gotta know. I'm sorry. What are you doing after
I'm
high
still
school?
not sure, but I really like how circuit this kind of things work. So it might be an
Excellent.
option.
And she's a
Hey.
freshman.
Oh,
Oh,
nice.
nice.
Hey, we'll take an option. We'll take an option. Just keep taking more ET labs and maybe that'll turn into something more definitive. All
We've
right.
got one more real quick.
Oh, go
Let's
ahead.
do, oh, nice. Double trouble.
So this one's powered with a pulley system.
Nice. I love the pulley, man. Great job.
Right.
Hey, can I see the bottom of it? Can I see the bottom real quick? Oh, look at that. Low friction with the straws. Yeah, all right. Cool. Have you all raced? Did you all set them up together and I'm not trying to make you all this a competition.
Not yet. However, I'll show you. Let's see. On my board, we've got our.
Oh, look at it.
We're ready.
Hey,
Very nice. They
ET
got
competition coming to a town
the
near you,
bracket. Yes.
2024. Come on. Let's closing the circuit. We almost need a countdown, Monica. We need
Yes.
to- Once we get these cars rolling, we can do a countdown. Texas is bringing it. It's a lot of pressure.
Oh.
It's a lot of pressure, I know. We hyped it up. I hyped it up too much. Bam! Whoa,
There it
that's
goes.
fast.
Oh yeah,
Jeez.
very nice.
Very, oh man, starting off strong, very strong. Excellent. Monica,
right.
you're doing such a great job navigating this whole
I'm
process.
going to,
You-
I have more Catholic that wanted to go next, but their camera's not on. More Catholic, are you ready?
Yes,
There
we
they
are.
go. All right. Putting the spotlight on more Catholic.
David. Oh, I have it backwards. 1 minute.
No,
All
it's
good.
okay.
Do not show my face. No, wait, switch. There we go. Okay, we're ready.
All right.
Oh, look at the professionalism. Look at the, whoa, sheesh.
We also, oh,
Moving.
and what did you do, Natalie? What? Oh, they want to know how you did it, what you did.
So we put like the two of the gears together and just
Gears. Oh,
And we have one more to show.
how many batteries do they have in there?
How many batteries?
just two.
Two
Two.
batteries, nice. Man, the
All right,
gears,
we have
that's
one
not
more,
easy.
David. Oh, not David. Steven. Steven, yours. They're coming, sorry.
So many teams got these gears
Here he
working. It's
comes.
amazing. It's amazing.
Here they go. And his left.
Oh, nice. Very cool.
Thank you.
Thank you. Hey, thank you for participating. Can't wait to see you in some more labs. Thank you,
All
more
right.
Catholic.
I let Omega know that she was next. I'm going to spotlight her, but her camera's not on. Can you turn your camera on? Oh, there she. All right. Let me spotlight her. All right. Are we ready?
Hey, how's it going?
Can you unmute so we can hear them?
Yeah,
There we go.
Hey, we can hear the energy now.
Yes.
So our
Yeah.
special feature is that we have a detachable wheel. Because we
Okay.
feel like putting the wheel.
I love it. Detachable wheel. They go with the propeller style model. This is definitely a tougher challenge, folks. We'll see. This is definitely a tougher challenge. I love it.
They took it to the next level over there at Ace.
That's right.
Oh, there
That
it
is
goes.
a-
Yes.
Wow, that's really fast for a propeller-based design. Now, we have some
Very
great,
nice.
yeah. You all, very nice.
Okay.
All right.
Are
We're
they,
going-
okay, all right, we're going to another one?
We're going
Very
to
good.
Atlantic. Now I lost my little, where's it? There it is. Atlantic Technical. You guys are up. Are you ready? If you could unmute so we can hear you.
Wait, is it
Hey.
working?
Unmute.
Are we muted?
You're on mute. Yeah, we can hear you.
Great to see you all. Excellent. Nice.
Let's
Yeah,
focus on
ready to
me.
go. Let's do it. Oh, nice
design.
design. Nice design. You know, there we go. There we go. Yeah,
Ready.
yeah.
All right. So we have, I don't know if you would call this chain link, but the batteries, you got two sets of double batteries.
Wow.
What would you call it? They're just chain.
They're just like chained together.
Yeah, they're chained. And then we got a little fan in the back, and then we got a flag. That's really it. Nothing crazy about it.
I
But it
love the
moves us.
flag. So you place the batteries in either series or parallel, getting a little more power.
On
the table, see if you want. All right.
Tell them to follow.
Oh,
Is it gonna go on the table?
But the
Yeah.
things that like I want something.
gotta put it on the table. Yeah, it's not gonna. it's not-
Yeah,
It's
yeah.
not.
I don't know if they can hear us, but that's a great looking classroom.
It's okay.
Oh, okay.
Hold on. Don't try to- Technical problem. Hold on.
All good, all good. Hey, engineering, it's all about problem solving.
It was working. It was. It's just a table.
It's
I
the-
believe you.
that's
I
it.
believe you. Without a doubt.
It's just.
Close that circuit. Gotta get that circuit closed. It's
Oh, there it
nice.
goes.
Bam, excellent job. Very nice. They're gonna go
Very
back the other
nice.
way.
Hartford, you're up
Sweet.
next.
Great design. Very, oh, look at that. I love it.
Very nice. Great job.
Great job, man.
All
We got
right,
some
I have
great things
Hartford who
today.
has their hand up. They have their car in the camera. Are you guys ready?
Yes.
Yes.
All
Wow.
right.
So this is our car. We have a belt-driven rear-wheel drive system for our car.
Ooh, rear wheel drive, very nice. Did you hear the explanation? Nice. Look at use the mounting, use the motor mount. Very nice. Hey, can we see the bottom? Yeah. Oh, got the batteries on the bottom like a real EV. Look at the stability. How you liking that, Mary? Jared, look at the stability. Look at that. Shout out to Mary, ET staff engineer on with us today. Great. You want?
You don't have to unless you want to. Okay, are you ready? Go to my side over here.
Whoever's right at the top.
Oh, gotta close the circuit. Very nice. You're closing it.
Let it go.
Oh, look, real-time engineering. Real-time engineering.
No pressure.
No, yeah, no pressure. Hey, we're proud of you if it works or not. This isn't easy. Not at all. And you all engineered an electric vehicle in an hour. Sheesh.
Got it?
He's good. We should have used wire clips.
Oh,
I wonder if we're providing switches as well. I gotta look into that. But yeah.
We are
Ronald,
in
that-
electrical. We are in an electrical lab, so we should have used wire clips.
Oh, hello. I saw somebody just poke their head
I
in
see.
the camera.
I'm
How you
sorry, but
doing?
I think I'm gonna click over to BIH Bronx International High School. Looks like they have a race ready
got
to
it.
go in one of their.
Oh, they got it.
All
They
right,
got
go
it.
ahead. All right, sorry.
Let it
sorry.
go.
Go.
I was
Yeah.
going faster than last time.
Nice.
All right. I was going to AOIT next, but their camera's not on. So I'm going to
Thank
go
you,
to
Hartford Technical.
I see Bronx Internet.
No, AOIT is here. We're ready.
Oh, am I in the wrong group then? I have, hold on. I see no camera on. I'm going to this group here. I see 2 EVs lined up. Is this a race at Bronx International High School? Mr. Elgin Scrass and Miss Massa? Room 302. Are you guys ready?
Who's gonna win? Red or blue?
That's right. Who's gonna win, red or blue?
Let's see.
Oh.
Oh, there they go.
Oh, look at that.
Blue had a little head start
Yeah,
though.
they did. For a fan-based car, those cars are cooking.
Very, very nice. Thank
Wow.
you so much. All right, we are gonna AOIT. I'm not sure which room has the camera on. I see one has the hand up, but there's no camera, so I can't spotlight you. There we go. Okay. Now you're on mute though.
There we go.
There you go.
What team represent? Word. So we're live. We got like this. It looks like a go-kart, but like it fell and broke, so it still worked though.
Okay, it looks really nice. I
Still haven't figured out how to connect this to the battery.
Oh, look at that. Got the solar panel going too. Hey, let's talk about that. We got to talk about that. How to connect them. That's good. We're ready. We're ready when you are. It looks great.
You're not gonna do it at the same time or one at a time?
This is my cart. Actually, we connected. This is very simple, but I like to say less is more. So
Okay.
it's basically just
Two cars.
Two
cars. Sweet.
Very nice.
Thank you.
Yeah.
It went on a race. Mine's actually pretty quick.
Are you guys gonna race them for us?
Yeah.
Yeah.
Yes. All right. I hear it.
Yeah, we hear them. We just don't see them yet.
Oh, there we go.
Oh,
Oh,
oh man.
one got it.
What? Yeah.
It's gone.
All right, great job.
Very nice.
All right, I have.
Run it back.
Okay, they want to run it back. They want
They
to
want to
run
run
it
it back. Where'd they go? Oh.
3, 2, 1, go.
Okay, great. There it is. Excellent job. AOIT High School.
Very nice. All right, thank you for sharing. All
Great
right,
job.
I have I have a lot of high schools with their hands up, but who's ready right now? Tara, Falston, who's ready? Falston, okay, I'm gonna spotlight you guys. There you go, you can unmute.
All right, guys.
Got a little feedback there.
First, give us 1 second.
All good. Oh, that's much better.
Yeah.
Able to vote if you guys can hear us.
Nice.
So if you can hear me.
Oh, wow.
What?
Amphibious car. It works in the water perfectly, on the ground, not so much. But yes.
Oh, I love that you took the challenge. I love you
It's
took the
powered by
challenge.
battery connected.
Look at that.
And the water bottles act as like pontoons almost. And it goes
Excellent.
across the water pretty fast.
Who's
Sweet.
next, guys? Oh,
Excellent job. If you all have some video of it operating in
we got one
water,
more coming.
we would love to see that. We'd love to see
One
it.
more is coming up.
Yeah.
We'll show it. You ready? Good.
Oh, nice. Hey, we see it. It's rolling.
There it goes.
Oh, yes. Give it a little push. Nice.
Cool. Yeah, it works.
No, that's excellent.
Thank you,
Very
guys.
nice. Thank you.
Excellent job. All right. Is Preston, did you troubleshoot that? Are you ready to show that one again or not yet? All right. Oh, they came running. Hold on. Here they go. All right, Preston.
All right,
We got it
two.
working. Oh, you got two. All right.
All right, so show that one. We had a little circuit issue.
That's all good. That's
Oh,
engineering.
I can't see it. Right there it goes.
Oh,
Very
it's
nice.
moving. Double fan. How you like that,
Double
Monica?
fan.
Double fans. Bam.
All right, and Leo, where's yours? Want to show it up here first? A little simpler
Very
one. One
nice.
fan, one battery.
Okay.
Oh, there it goes.
Sweet. Oh, it's cooking.
Going.
Building up momentum.
Oh, we got one more.
Oh, look at that. Look
Oh,
at
wow.
that. Ooh, the bottle design. Sleek.
Okay, go.
They have the fan
I can't see it
elevated
until it
really
starts on.
high.
Oh, there it goes.
Very nice.
Redirect.
Very nice. All right.
Excellent.
Tara, are you ready? I see your hand is up, but I just see wires. Are you ready to roll, Tara? Okay. I don't think they're ready. All right, we're gonna go to, I see Bronx International has another classroom that looks like they got a race ready.
Okay, Bronx.
There we go.
On the flat table.
Hi. So this
Hi.
How you doing?
is our Mesla. It has an M there. And this is the Model 6. It's a completely original name, not thing.
Model 6.
And we wanted to do like two, this thing, how are they calling this? Propellant, but it was too heavy. So we decided to put just one.
I love
And
it.
had the batteries inside so it could look a little more aesthetically pleasant.
They're
And
very
yeah, so
nice.
that's
Professional.
Thank you. So we're going to do like a little race.
All right.
Mine's is gonna win.
Oh,
I believe you.
They wanna
I like
see-
the confidence, right?
That's right. Someone in the background said, "We shall see." Okay.
All right.
All right, there we go.
They're on. They're ready.
Oh, look at that car.
Tres.
Nice.
Dos, uno.
Those cars are fast. Nice. Oh man.
Interference.
man.
Interference.
Oh,
Espérate. No, miss.
Great job, Bronx
excellent
International.
job. Very nice.
I have Academy of Mount St. Ursula. I know they've been trying to get that camera working. Are you ready, Academy of Mount St. Ursula? I don't know.
Okay.
There you go. Oh,
A little bit of feedback. Oh, not too bad.
Okay, go. I'll send the camera around probably today.
Here we go.
I'm
So I'm gonna
angling
just-
my view, right?
That's right.
Tilting a little
They're
bit.
taking us on a little ride. It's like a
Yeah.
roller coaster.
Okay.
All right, there we go. Oh, I see the propeller moving. There it goes.
Oh, it's going. Very nice.
Great job, ladies.
I'm orienting my head.
Thank
What's
you.
it? Like that?
Oh,
Very
oh,
nice. Still
oh,
going.
she picking up the
It's
speed.
picking. Yeah, look at the momentum. Excellent job. Very nice.
All right, Milton, I think we have like 4 minutes left. You want me to show somebody else or you want to talk a little bit? You tell me.
I think we'll take one more because I see so many hands raised.
I know,
And
I
you all can
know.
always send us a video, and maybe if we can, we'll spotlight you on social media, right? If you allow us, we can spotlight you on social media. So one more group.
One more group. Who's ready right now? Come to the camera right now. Because I see groups that have their hands up, but oh, Duval is waving their hand. Duval, you won the race, Duval. All right, go for it. You're on mute, Duval. Can we unmute so we can hear you?
Hey, Duval, can't hear you yet.
Yeah.
Oh, say 1 second. All right.
Okay.
I'm muting. Duval High School.
All right, here we go.
Let's
All right.
go.
Go ahead.
Yeah, come on in.
Put them in the ground.
Oh.
Uh-oh.
Wow, everything looks great, man.
All
Wow.
right, see it moving. Got a little, very nice.
Oh, there it is.
Great. Thank you, Duval High School, for
Great job.
wrapping us up. Excellent. Hey, we can't say enough about this day. I mean, I don't know, Monica, have we ever seen so many vehicles just absolutely kill it in one day? You
I
all
have
did.
super impressed with the amount of working cars. Even though they had to troubleshoot some, they made them work some amazing races.
That's right.
Yes.
You all are you're like real engineers. We talked some about this. Hey, nothing wrong with a little competition. So as you're continuing to develop these different products that you have, excellent products, excellent vehicles, always think about this. The speed challenge, that's great because speed demonstrates that you're using less materials. Less materials means speed. Straight line challenge. Some of you all are using pulleys and gears. The ability for you to go straight also demonstrates that you've made a really, really good design. And finally, efficiency, right? Efficiency is important. So one thing you could do, if you have a race and there's a car that's really, really fast, but it's really heavy, try to find the car that has the greatest speed to mass ratio. That means that you're using less critical resources. Some of you all took on the challenge of just operating this car with one battery. That's outstanding, right? The less materials, the better for our environment. If you enjoyed this field, there are some absolutely awesome engineering disciplines for you to get involved with. What's not listed on here is computer science, which we alluded to in the video earlier. These cars are becoming automated. So things like machine learning, sensory, artificial intelligence, all that stuff is very important with vehicles, in addition to electrical engineering, mechanical engineering, chemical. Think about the chemistry of the battery, more efficient batteries, more efficient solar panels, for some of you all who worked on the solar panel, and even a material scientist. Now we have ranges of salaries on this page. Trust us, I'm a hiring manager. It's higher than even this. We need you. We need all of you who are interested in engineering to get involved in these different fields and take us to the next level. And you don't have to wait. You don't have to wait. There are opportunities like internships that are available right now. What you all did today, there are so many people, Amazon, Tesla, NASA, the Applied Physics Lab, Google, that would love to hire you just with the skills you have now and they provide internships if you're 16 years or older. So we'll put some information in the chat about that. But one thing it takes is you all have some great products that you made today. You know, that's part of your reputation, that good results, great. It's also about, you know, other people knowing those great results. So we are really advising you to get involved with other organizations like the Society of Women Engineering, or AIAA for aerospace, or ASME for mechanical engineering, and NSBE, National Society of Black Engineers. The more and more people know about your great talents, the more and more you'll have the ability to really operate in your field. And if you enjoyed this, you know, we want you to continue to explore. We talk some about that with some of these different disciplines for sure. Continue to explore. Also, you know, I think they're going to put in the chat soon, there's a lot more Engineering Tomorrow opportunities and labs you can get involved with. A lot of these special lab days, which, you know, Megan and Constance have kind of created these awesome days for us to reach folks from across the country. You know, please get involved. And when I talk about getting involved, I have to say, I have the honor and the pleasure to introduce an awesome speaker. Can't beat it. Chief Diversity of Equity and Inclusion Officer at GM Motors. She led the development and execution of strategies that make a positive change in high-performing, inclusive culture, equitable systems, maximizing the power of diversity. She's strong advocate in the community. She serves on multiple volunteer organizations, including Engineering Tomorrow. We're so blessed to have her, but also the Girl Scouts of Southeastern Michigan, where she is the chair of the board of directors. And she's just a strong advocate in general for volunteering. Hey, Purdue University, that's my alma mater. We're representing that together. And it's perfect that she's here for EV Day, because not only does she have a bachelor's in electrical engineering, she has a master's in electrical engineering and a minor in biomedical. So without further ado, I want to introduce you to Telva Magruder. Let me stop sharing my screen. Telva.
Hello, Milton. Thank you for that fantastic introduction. And I love that slide. You need to send that to me.
You
that
can
was
have
great. I am infinitely grateful to be able to spend time today with all of you, every single person on here, from every school, all of the students and the teachers. And I'm going to spend some time talking to you about some things that I hope will be helpful for you on your journey. And before I say that, let me just say, yes. Oh my gosh. Those vehicles that I just saw, that you all just did in about 1 hour, fantastic. I got to sit in one of the breakout rooms and watch you kind of work it out and ask questions and figure it out and try again. And even now when you were demonstrating, you know, say, okay, let's figure this out. Like, that is what we do, right? That's what engineers do. We do it together, we figure it out, we fall down 7 times and get up 8, right? Because we know that we're going to be able to solve a problem, and we do it with other engineers, with technology people, with skilled trades people. Like, we make amazing things happen for this world. And so I'm going to talk to you a little bit about my journey and a little bit about what I do at General Motors and at my company. And hopefully you all are so energized that I help you build even more energy. So I'm going to share my screen. Every app is different. Maybe. Here we go. Okay.
Awesome.
There we are. And so there we go. All right. I'm going to talk to you about taking the leap and about creating new beginnings at every step of your life. This is super exciting for me, with all of you super creative, curious, challenge ready students. I'm thankful to give this presentation to you because you matter. And everything is about taking the leap. You know, all of us on any given day, myself included, on this day, am wondering, do I have what it takes to do something that's on my mind? Do I have what it takes to figure out the things that I need to figure out? You know, some days it seems like a lot. Some days it seems like there's nothing that's working in your favor, right? And what we have to do on all of those days is figure out what is working in our favor, because there's never a complete void. There's always something. Engineering tomorrow, this experience you're having right now is working in your favor. And what leap might it inspire you to take today? So for me, my first beginning was with this thing that you see on the screen on the left-hand side. And what you see on the left-hand side is an artificial heart. And on the right-hand side, you see a real heart. And in the early 80s, and those of you that like math, which many of you may, can do the math and figure out how old I am, but I was right about to start high school. And I was watching a television show, and it was about the implantation of the first artificial heart. And there was this doctor, and his name was Robert Jarvik, who had designed this heart working with some engineers. And they successfully implanted this heart in a human for the first time. And there was a show about it, and I'm watching this show, and I'm just completely shocked, Like, how is that even possible? You basically have a mechanical device that's going to go into a human body, and it's going to pump blood for them, right? And you see the artificial heart has a left ventricle and a right ventricle, just like the real heart. And it's got pumps, and it's got flow, and it's got, you know, it's got connections to the real arteries in the human body. And this man lived, the one that received the artificial heart. But when I got done with the show, I was like, you know, we can pretend that's me. You know, my hair wasn't that cute back then, but we'll pretend. When I got done with that show, I was like, oh, like, wait a minute, like, that's cool. I would love to be able to do something like that. And I had considered being a doctor, but then I was also hearing about these people that the doctor worked with that were called engineers, and I didn't know what an engineer was. And so here I was, you know, almost 14 years old. I didn't know what an engineer was. So I went and asked my dad. My dad said, well, you know, isn't that like the people that drive the train? And I was like, no, this person helped make a heart, you know? And so he told me what he always told me, which at the time had to be said, which was go to the library, right? We didn't have Google, couldn't look it up, wasn't happening. So I did that, and I started doing research. Now we do that today, right? We do research and we figure out things that we're curious about. And so that's what I did. And I spent a lot of time trying to figure out what this engineering thing is, because I had heard about the doctor thing. And in that, I learned about mechanical engineering, and this is a mechanical heart. I learned about electrical engineering, and I learned about chemical engineering. And I decided, I said, you know, I think I want to be an engineer. I think I want to help people. You know, so whereas before I was thinking, you know, I want to be a doctor, I thought I can help people this way. And I went to my school guidance counselor and I said, you know, I think I want to be an engineer. And this was a long time ago, right? And the guidance counselor said, well, Telva, you know, you're doing well in school, but you know, there aren't many women in engineering. And there really aren't many Black people in engineering. It could be a really hard course for you. And I'm not sure if you really want to do that. So that wasn't exactly encouraging. But I had been inspired by what I'd read and what I had learned watching that show. And I thought, you know, I think I really do want to do this. So I continued to work in school. I didn't have organizations like Engineering Tomorrow that could give me experiences like the one you had today. But I was inspired, just like hopefully you are today. And so I kept going. And I don't know if you can see this. I hope you can see this, but if you can't, up the top, it says, you know, consistent beginnings, and we have to build building blocks so that we can grow. And so, you know, you all built electric vehicles today. We have these things called letters that build words, and words build sentences, and sentences build stories, and stories turn into books, right? You know, everything that we do is about building the small building blocks of language, of math, of science, one at a time, and putting them together and forming amazing things that allow us to take leaps. Ideas like beauty, like happiness, like truth, create things that wouldn't otherwise be created when you put them together and allow them to form a string of actions and experiences for people. And so I just started kind of doing the things that I needed to do. I kept going to school, I kept doing well, I would read, I would learn, and I would ask a lot of questions of people that didn't necessarily want to hear them. But what I was doing that whole time was gathering information and trying to figure out how to do what I need to do. And so I kept going. And eventually, life happened, and I'm going to tell you a little bit more about that. And I've landed at the place where I'm at right now, where I have a wonderful family. I have a wonderful husband and 3 children. He's a great partner. I'm able to do a lot of things that make me happy. And I volunteer a lot of my time, like Milton mentioned earlier, with Engineering Tomorrow, Girl Scouts, and other organizations. And so I'll talk about my journey. So as was mentioned, eventually I got to go to Purdue. And how did that happen? It just so happened that the university reached out to my school because they had seen my test scores, and they said, you know, you have a student there, and several students actually at my school, that we may be interested in supporting through a program. And it was called Minority Introduction to Engineering. And so Minority Introduction to Engineering, offered by what would soon become my university, was my way that I started learning about engineering, and where I got some experiences like the one you got today and in other ET labs that you may have experienced so far. And by the time that happened, I kind of knew I wanted to be an electrical engineer. And more specifically, I wanted to be a biomedical engineer because I want to design devices that could help people. And so through that experience with Purdue, I applied to a lot of engineering schools. It really solidified that's what I want to do. And I got in to Purdue and was fortunate to be able to go to Purdue with a scholarship as well, which was provided by NASA, where Milton is, and which is an absolutely phenomenal organization, and one that breeds fantastic talent that does amazing things. And so I was really fortunate to be able to have experience with NASA. And ultimately, when I graduated after working with NASA during the summers and after them helping to pay for my education, I was able to hire in with a company that was a contractor to NASA called Sphere Technologies. And I started there as what's called a test operations engineer. And so you'll see the second picture, like this girl in a hard hat, like that was me, a hard hat with prints in her hands. And I would instrument test labs that were testing combustion engines and that were testing de-icing mechanisms for planes, and even instrumentation for the supersonic wind tunnels that we had at the NASA center that I worked at. And it was very hands-on and very intricate, and a lot of, device programming with programmable logic controllers and things like that. Very hands-on, very in the dirt. It was awesome. And it was great learning because I was able to see so many different types of technologies, and I was able to use what I had learned in electrical engineering school at work, but I was also able to start learning mechanical concepts. And so I did that for a little while. And then I transitioned to General Motors and started in a manufacturing plant in Indiana. So I've been at a research center in Ohio, the NASA Lewis, now NASA Glenn Research Center in Ohio. And then I moved over to General Motors as a controls engineer because I knew all these device controls and I knew programming and I knew robots. And so I started with General Motors and I worked on programming and automation for machinery and equipment. and a lot of major equipment projects where I got into a lot of high voltage work and a lot of robotic control, which is very, very important that you keep people safe while you do that. So I was able to do that and design new machines and upgrade machines and keep equipment running so that we could produce the vehicles that we were producing. And at the time I was in a truck plant that made about a million parts per year. So we were always working, very busy. And eventually my career continued to evolve, and I was able to lead, I was able to be a leader in manufacturing engineering, which means I wasn't working in a manufacturing plant anymore. I was working at headquarters where I was planning years ahead of time what machines we would put into our sites, and then working with the engineers and other project managers in designing and building those machines. And these are multi-million-dollar machines. And what's really cool about this evolution, every single thing I'm talking to you about was a new beginning for me. I went to school as an electrical engineer. I learned how to program devices when I went to NASA. I learned how to program controllers. I learned how to program robots. I didn't know how to do any of those things, but I figured it out because one thing engineering school does is it teaches you how to solve problems. It also teaches you that you can't do many things alone. So you work in teams, you work with skilled trades, you work with technologists, and you all solve problems together. And so everything I did was a new beginning, but I always had the foundation that I could build upon. The other thing that was great about what was going on, I was born in Dayton, Ohio. I went to school in Indiana at Purdue. I went and worked back in Ohio, and then I went back to Indiana to start at General Motors. General Motors gave me the opportunity to have an assignment in Canada, and so I worked in Ontario, Canada for a few years before I relocated to Michigan, where I am right now. And so not only was I having new beginnings from a technical perspective, but I was having new beginnings from a personal perspective, meeting new people, new technical people and people in my personal life in many different locations. And I was building up interests in things both inside and outside of the company, which I'll talk about in a second. And as my career progressed, I became a manager. So you'll see that here at the upper right. That's like, you know, somebody in fancy clothes. But I've never lost my desire to be in the middle of things, you know, creating things, building things, helping robotics teams, helping students like you. But I became a manager and learned to lead people and do that well. And then I also had the opportunity to move on in my career from manufacturing engineering to facility engineering. And I led the entire global facility team for General Motors. So what does that mean? I was in an organization called Sustainable Workplaces, where we do everything for the workplace for every person at GM. So my engineering team was structural engineers and civil engineers and mechanical engineers and electrical engineers and environmental engineers, architects. And that team together, we built manufacturing plants, we built office buildings, we built proving grounds to test new vehicles, including electric vehicles. We built warehouses. We did all kinds of things all over the world. And so once again, new beginnings. I didn't know anything about architecture, right? I didn't know anything about civil engineering, but guess what? I learned a lot and I was able to support my team, and we all learned from each other. And then most recently, I moved into leading diversity, equity, and inclusion for the company. And you might say, like, first of all, what is that? And what that is, it's a very people-focused role where we ensure that everybody at the company has a great chance to succeed, particularly those that maybe due to societal or historical situations in different parts of the world haven't had as much opportunity. So that includes women in engineering. That includes, you know, people that are Hispanic or they're Black, or, you know, that maybe have come from Brazil and the Latino population, people that have disabilities in engineering, and I'm sorry, throughout the company. And so what we're doing is we're ensuring that the people with diverse backgrounds can come in to a really high performing organization and do exceptionally well. Throughout my career, I've been able to travel the world. in doing all the things that I described. And so, you know, the future is bright and the future is also challenging. So I mentioned that I had done a lot of things and I volunteer in a lot of places. And so I'm going to talk about that really quickly, but I need to take a quick second because I think wherever my laptop is plugged in, it doesn't have power. So I need to switch my power cord for just a second. Hold on one sec.
Gotta have power.
Yeah, I don't know what's going on, but I didn't want to lose you there. So I'm back. Okay. So these are pictures of me doing different things. I'm a swim official. I was a robotics mentor for many, many years. I'm a Girl Scout. I'm a martial artist. I'm a professional. This is me teaching a young man at our dojo. I spend time, so it's important in life, no matter what you do, no matter what age you are, from right now to wherever you go in life, that you spend time developing yourself, but also contribute to the community and also give yourself time, right? Give yourself time to do the things that you want to do and that you enjoy, because that helps you grow. And the other great thing about contributing in different places is those are new beginnings. Those are places where you learn more about yourself, you learn what you're interested in, you can apply it, and then you can use it in other places. You know, even today, when I was listening to you all share what you shared in terms of the electric vehicles that you've created, and I listened to how you work through some of your challenges, it gave me a couple things to think about, right? So I'm growing from you. Just as you're growing from your experience with Engineering Tomorrow today. And so I highly encourage you to figure out where you can give and grow and take on new challenges, because our presence as people is always evolving every single day with every experience that we have, right? And we get to make decisions, even though there are times when it may not feel like all the decisions are ours. Particularly now, you're still in high school and your parents may have something to say, or your grandparents or your teachers, but we have the ability to make decisions that lead us into the future. And I just want to give out a shout out to all the young ladies on the call today. You know, this is a patch that I designed for Girl Scouts as I lead the board on the Girl Scouts right now, but lead like a girl is one of my favorite sayings. And so, and hopefully you can take that away. You know, leadership is something that we all can do, and we all can do it in our own way. So, you know, regardless of how you identify, leadership is something that you will always be doing in anything that you do. And so it's just by virtue of setting that example and being who you are. Okay, so I'm going to pivot a little bit. That's a bit about me, how I grew up, and you can ask questions later. I want to shift and talk a little bit about this world we're in. You all just experienced a great lab, and you practice building vehicles that are powered by electricity. And you also learned a little bit about solar panels, which can harness power from the sun and generate power then for things that can be powered, you know, by electricity. So now you have renewable energy powering that vehicle, which is super exciting. This is something that we couldn't have imagined, let's call it 70 years ago. And when solar panels first were created, they were so expensive that very, very few companies could even afford to think about utilizing them. And now the technology has evolved with the help of engineers to the point where people have solar panels on their homes, and that technology will continue to evolve. And that's one example of how technology evolves, and it's literally changing the face of the future of energy at this point. So we're in a very, very rapidly changing world, and we're in one where we're talking about having vehicles powered by alternative sources, whether that be batteries, fuel cells. I mean, I could go on and on and on, but this is not the 20th century anymore, right? This is the 21st century, and we're doing amazing things. And the question is, how might you be prepared? Well, a couple things. So this is a slide that I really love from my company, from General Motors, where we have the opportunity to right now to be working with another great organization that you already know I love, which is Lockheed Martin and NASA. And we're working to innovate for the future of lunar landings, right? But here's the deal. Engineers innovate. That's what we do. And born to innovate may be a little bit misleading, but what it really means is when we have curiosity and we build skill, whether it's going to activities like the one you have today, eventually going to engineering school, et cetera, we create a capacity to innovate, to do things that have never been done before. And when we have that capacity, we need to use that capacity. And so you have engineers all over the world and that are using their capacity to innovate to change the future. That is what creates this rapidly changing world when combined with many other disciplines and things like that. But without the people that are building the skill to innovate and then using that capacity to innovate, that change doesn't actually occur. But it does occur, right? And people like you, students like you, turn into professionals like me that literally change the world. This is a ventilator, and all of us have recently been through the pandemic. And as you know, General Motors is a car company. But during the pandemic, what we needed was not cars, right? Because no one was going anywhere. What we needed was to keep people alive. And so here we are, a company of engineers and a lot of other technical people, finance people and technologists and researchers and designers. And we thought, you know what, we think we can help. And so we partnered with a company that designed and built ventilators, but they were building them at a very slow speed. And we said, we think we can help you. We think we can partner with you and help you manufacture these ventilators at a faster speed. And that is going to help keep people alive during this pandemic. And so here we are, people built to make vehicles that all of a sudden we're working to figure out how to make ventilators. And I think it's a great story about the power of engineering. Because once again, engineers solve problems. They learn how to think. They don't know what all the problems are going to be. They don't know all the answers ahead of time. So here we are with a brand new problem, something we've never thought about. And working in teams and listening well to each other and hearing from other people's experiences, which is what we do when we have diverse environments with people from different backgrounds, with different experiences. We were able to ramp up ventilator production to rates that were going to help save lives in the United States. And do that basically starting from almost nothing, starting from a simple process. And we said we can make that process better. We can make that process faster. We can make sure we don't sacrifice quality. We can do it while keeping people safe that are doing the work, and we can ensure the safety of people that use this equipment, right? All within a matter of weeks. So we went from 0 to full production in a couple months, and that's what engineering can do. Super exciting. So Milton had a picture that highlighted a little bit of this earlier, but this is the batteries, the Ultium batteries that power our electric vehicles at General Motors. What's really cool about the Ultium batteries, these are some of the battery packs down here at the bottom of this vehicle chassis. What's super cool about them is they stack like Lego blocks, right? So for different size vehicles, we can have different battery configurations. Why is this important? Well, it's important because we know that in order for everyone to have access to electric vehicles, this is an equity consideration in terms of transitioning to electric vehicles, we have to have vehicles that are different sizes and at different price points. And so what we chose to do was to design an architecture that can vary so that we can have vehicles at different sizes and different price points so that people can find an electric vehicle that's going to fit them over time as we start to launch electric vehicles. So those base foundations of the battery and the battery design and how it stacks and how it goes together are very important to how we're looking at electric vehicles in the future. Different companies are going to do this different ways. One of the other exciting things about engineering, there's more than one way to solve a problem. But the point being that what's really important as we move forward is that electric vehicles are available to people that need them for their life and their livelihoods, and they'll be able to reach them at different price points. So this idea is us bringing everybody in, right? So using the diversity of our team to bring everyone into the future that we're creating in the automotive industry, and frankly, beyond that industry, because many types of mobility will be powered by alternative power sources. And so when we think about vehicles specifically, we want to ensure that the diverse team that we have at our company and the diverse teams at other companies are bringing their experiences and their awareness of what's going to be necessary to reach people in all different communities, bringing it to bear in the designs that we're creating, and then offering those designs to people from all different backgrounds with all different needs. And so the idea of diversity, as I tell you a little bit about the importance of diversity and equity and inclusion, is the fact that having diverse people working on engineering teams creates outcomes that are going to benefit more people. So if you have women on teams, if you have disabled people on teams, if you have people that grew up in urban environments in the city and people that grew up on the farms and people that grew up in the suburbs and people that have lived in India, people that have lived in Mexico and people that have lived in the United States together working on teams, then when you're trying to do something that's meant for people around the world, you have a much better chance of doing that well and of continuously improving what you've done. And I already saw all of you out there working on continuous improvement on your vehicles, even on the screen, which was absolutely awesome. And that's what we do. So diversity helps ensure that the products that are being created are going to meet the needs of the customers that you want to reach. And all of that product creation, right? So we've talked about lunar rovers, we've talked about electric vehicles, I could talk about last mile delivery vehicles and all these different things that are powered by alternative energy sources. All of this happens because of people, all of it. None of it happens without people. And by the way, when people talk about companies are kind of made up of people, right? It's not some entity, it's a group of people doing great things, ideally, right? And so when you think about inclusion, so I've talked a bit about equity in terms of equity of everyone getting an electric vehicle, talked a bit about diversity, the diversity of people that are driving the progress. And then there's this idea of inclusion. Inclusion is about ensuring that the ideas of all of those diverse people are actually coming to bear. What I like to say is that inclusion leads. Inclusion is the fact that is honoring the fact that you matter as an individual, creating an environment where you are valued, where your ideas will be heard, where your ideas can be maybe moshed together with other people's ideas so that you can come out with a great solution. Because every time your idea is heard doesn't mean that's the one that's picked. I'm sure you all learned that today, right? Inclusion means creating an environment where people feel comfortable being themselves. And so when you create an environment where people feel comfortable being themselves, feel comfortable asking questions, feel comfortable bringing forward their ideas, and you couple that with an equitable environment where people get what they need to succeed, right? Regardless of kind of what their starting point is, then all that diversity that exists naturally in all of the different people will actually power a much stronger progress than if we just bring people together and say, get something done. So my current role is to take diversity, equity, and inclusion and make it such that it goes to work in the business and the business does more impactful work because of it. So with diversity, equity, and inclusion, we value perspective of team members. We support each other. We work well in teams. We're constantly building skills so that people have the opportunity to continue to grow. We're very transparent about how we do things. So we're very honest about what's working well and what's not. That includes our business. That includes our progress with people and diversity in the workplace. And doing all of that helps us innovate better. It helps us be more agile, and it helps us grow both as individuals and as a company. So that's kind of how it all goes together. Now, I want to talk really briefly about skills, because you all may be wondering, like, okay, at a company like GM, what kind of skills are necessary? Well, we bring in a lot of engineers into our company of all different types. You've heard me name almost every type of engineer, including chemical, including material engineers. We have them as well in our company, and I could go on and on. Aerospace engineers are at General Motors as well. And so we hire a lot of engineers. We also bring in people that are in the skilled trades to help us actually install all of that machinery and equipment I talked about earlier and run it and make sure it continues to run well and keep people safe. We have a lot of technology team members that have different technical skills that fill in some really important gaps that can't exist if the company is going to perform well. We look for people that are agile, people that are willing to learn, people that have the ability to fail and stand back up and keep going, people that'll speak up, people that will ask questions, people that are curious, and ones that know how to start over when something isn't going the way it was originally planned. So people have tenacity, stick-to-itiveness, a bit of grit, right? A bit of, don't quit. Really, really important. And people that know how to admit sometimes when they've made a mistake. Okay. That's what we are certainly looking for. So I'll end with this. There were a couple questions that came in ahead of time in terms of, how are we preparing for the all-electric future in terms of giving people the skills that they need? We do a few things at General Motors, and I work with a lot of other companies in the job I'm in right now. And I'll tell you, what I'm telling you right now is what many large companies like ours and organizations like NASA and different agencies are doing. We skill people inside of the business. So, the electric vehicle itself, what's interesting is a lot of the vehicle, about 80% of the vehicle is the same as, the internal combustion engines. About 20% of the vehicle changes. And so one thing we have to do is continue to skill team members on both the legacy portions of the vehicle, because those are evolving as well. They're becoming more digital, more user interaction, more ADAS. I don't want to use too many acronyms, but there's the traditional part of the vehicle is also evolving. And so we make sure that our team members have skills so that they can make that evolution happen and that they can create those vehicles. And then we also identify way ahead of time what skill sets are going to be needed for the major components that are changing. And so we identify those, and then we determine how we're going to skill up. Sometimes we hire people with those new skills, and then a lot of times we create training within the company for people that are both salaried and working hourly jobs, maybe skilled trades, maybe engineers, to build the skill they need for the new technology. And we do that all while making sure that people are safe. So we kind of use our strengths, which is launching new vehicles, and then we add to it with new skills. But then we also partner with other organizations that can help us think about what we need to be paying attention to. So we don't think that we know it all on our own. So we talk to other companies, and we talk to governmental agencies, and we talk to community partners, and sometimes we form partnerships with different organizations with different key skills so that we can be kind of on the bleeding edge, the front edge of knowledge, and make great decisions. And then the last thing we do is we partner with community organizations, because sometimes the skill that needs to be built is better built by a workforce development company or organization that's outside of our company. And so we partner with them to build skills, and then we hire people into our business from the communities where we're working. And so we put all of that together, and that's kind of how we ensure that we're going to have the right people for the electric future. Okay. And similarly, we also use partnerships and community to make sure that as we move forward in electric vehicles, that we're going to have the infrastructure for charging, that we're going to be moving toward more renewable energy sources and things like that, that we're going to have resiliency in our power grid. So that also takes partnerships and community engagement so that we can get all the pieces of the puzzle put together. Okay. So with that, I hope you're confident. You know, I've had a great journey, and from the moment I had no idea what an engineer was, through my career where I've you know, designed machines that are bigger than most people's houses. I've launched all kinds of vehicles. I've put together, you know, really cool technical solutions that we had no clue of in the beginning. And all of that has been in the interest of creating a better, more sustainable future. And so I'm really glad to have been able to participate in that, and know that you can do the same. So take the leap, because it's really about embracing all those new beginnings and opportunities and not ignoring your curiosities and the ideas that you have. So with that, I'm going to stop this sharing and open it up for questions.
Man, that was absolutely outstanding, Tel. I just want to say on behalf of Engineering Tomorrow, thank you so much. I took some excellent nuggets from you while we're getting folks to jump in on questions. Your love to solve problems, the born to innovate. I love GM's versatility during the pandemic to respond and pull all those engineering and scientific and all those resources to respond in the pandemic. Nothing happens without people. That's powerful. We lose sight of that. We think of resources, we think of money, we forget the people. And diversity powers progress, the diversity of thought. Sheesh, give yourself time. That's what I struggle with. You know, oh, I'm just trying to do too much. Give yourself time. And then I just love, like, it seems like you've reached the pinnacles of success, but you're constantly pulling other people up with you. And it's inspiring. We thank you for this time. Hey, let's go with the questions. Let me stop. I'll be here all day, just kind of throwing out the accolades. It's just excellent.
Thank you, Milton. It's like I said, it's my pleasure to be here. And I know you all pre-submitted a bunch of questions. I tried to answer some, but please don't be shy. You can ask anything, even if it's not related to something I specifically spoke about. Please don't be shy.
Yeah, if you all don't start asking, I think, you know, a bunch of ET folks will start jumping in. I got so many questions myself. Yeah, ask some questions. Let's do it. Let me look at the list of questions that were captured as well. Those were really,
we can go through those too. Yeah, I can start hitting on a couple of those actually. One thing I didn't hit on was the question is, how is GM working to increase the diversity of his engineers? Which is a great question from a Graham Brown school in Louisville, Kentucky. We had it from a couple schools, I think. And so what we do at General Motors is a few things. You know, the secret to increasing diversity is doing, first of all, things like this, where we're reaching out and we're inspiring or working to encourage, I'll say, people to pursue engineering degrees. Fundamentally, when it comes to women and underrepresented groups in engineering, one of the biggest challenges that we have is getting those constituencies into school. Okay. And so you have to reach, you know, people when they're young, like you, so that you can really think that it's an option for you. Okay. Because we need a higher percentage of women and a higher percentage of people in underrepresented groups to jump in. Okay. But then once that happens as a company, what we get to do is we lay out job descriptions. We work to do that in a way that it will attract people from all different backgrounds. And then we send that job description out. We don't want to write a job description the way we did 10 years ago, because, you know, frankly, a lot of people look at that and not be excited about it. So we write it so that it will attract a broad group of people. And then what we do is we have all kinds of great systems that say, you know, let's bring in all the qualified talent that we possibly can from different backgrounds. And we work to make sure we interview a diverse group of people for each role that's open, so that the likelihood that we hire a qualified person from whatever background is higher, okay? And we measure what we're doing. So, you know, we have set aspirational targets in terms of what we want our representation in the company to look like. And we use a ton of data analysis to do that with a lot of really, really smart people, so that it makes sense and it's fair for everyone involved. And then we work toward those.
Awesome. Awesome. There's like 3 questions in the chat right now. One of them is, what is one thing you've helped build that improves society?
Yeah.
Question.
Yeah, that is a fantastic question. You know, I am super excited. One of the things I'm really proud of, and when I was working leading facility engineering, one of the things that we did was work on energy reduction initiatives. And initially what we started working on was making sure that the company was using less energy as we were producing our vehicles, okay? But then at the same time, we were working on the source of our energy. And so we were working on increasing the amount of renewable energy that was powering our sites. And what we figured out, we committed that we were going to be, as a company, 100% renewable by the year 2050, okay? Wow. But what we needed at the time, and this was in 2016, but what we needed was a strategy to do that. And so what we did was we put together a strategy to get there. And we realized very quickly that we needed partnerships. So remember, I was talking about partnerships. Yeah. So we started partnering with utility companies. And we started talking to them about, okay, what are you doing to go renewable? Because for as long as we're getting power from you, you know, we can't reach our goals. And we realized that they needed some help. And so my team and I helped the local utility companies, and then eventually utility companies in the different states that we operate, develop an approach to increase the renewable energy assets that they had in their company. And then we help them, frankly, you know, in the case of, you know, regulated energy in states, we help them go to the states and get approval to make new energy offerings that were renewable. That, along with a lot of initiatives to reduce energy consumption in our company and redesign machines, which I was able to help with that as well in terms of using less energy. We've now got a goal that we're going to be 100% renewable in the United States by 2025, wow. Right? And in the world by 2030. So, you know, it's like, that is a huge difference. And we were able to also take advantage of that work so that the energy that's powering our charging infrastructure is much more renewable than it otherwise would have been. And so, you know, that makes a huge difference in terms of society.
Excellent. That's another really, really good question. I know that all engineers fail. How did you feel when you failed the first time? And this is coming from Ayana Moses. Shout out to Goose Creek High.
Thank you, Ayana, for that great, great question. Wow, I felt horrible, right? You know, I felt horrible. And I remember the first time that it really, really hit me. Like, there are a lot of little failures you have. Like, if you think about when you're trying to do a lab in school and you're like, I know this is gonna work, and it doesn't work, and you're like, you know, and it drives you crazy. You know, there's those moments. But then I remember this one moment. I was at GM, and we had a machine that wouldn't work. Okay. And I was what's called a controls engineer. So I was the electrical engineer, and my job was to make machines work. Right. And, you know, and so we had a machine, it was down, and it was an automation problem. And it had been down when I came into work. It had already been down for like 6 hours. So by the time I show up, You know, everyone is like, Telva, if we don't get this going, we're going to be flying parts from here to Texas, and it's going to cost the company thousands and thousands of dollars. And I was like, what? Wait a minute. You know, and so effectively, I had a couple hours in order to avoid that plane taking off to fly parts. And it took us 2 hours and 15 minutes. It wasn't good enough, right? It wasn't good enough. And we got the machine going, but it took us 2 hours and 15 minutes. And the company had to spend like, it was something like $25,000 to fly parts from where we were to where they needed to be so that we could make vehicles. And I was like a young engineer that was barely making that much money in a year. And so I'm like, oh my gosh, you know, but what, and I felt like no one would believe in me.
Yeah.
Right. And you know, and it didn't matter to me that they had been working on it for hours and hours before I showed up. And that by the time I showed up, there was only a couple hours left. It didn't matter. I felt like no one would believe in me. And I felt that, and it wasn't me working alone. You know, I was working in a team, but I was the electrical engineer and it was an electrical problem. And I wondered, like, was I not smart enough? You know, what was wrong with me? I wondered that. And what I realized was a few things. That I wasn't the first one that I had to fly part somewhere, right? You know, it wasn't the first time that happened, and it wouldn't be the last. What I realized was that what was most important was that I figured out why it took us so long that time and go to work on making sure that it wasn't going to take that long the next time. And once we figured out what the root cause of the problem was, we went to work at engineering a different solution so that that root cause could be eliminated, so that it would never happen again that way. And I realized that people would believe in me as long as I showed that I was going to keep moving forward, right? That I was going to figure out how to not let that happen again. And so when we did that, then we shared it. Okay, here's what we did for that problem that we had a few weeks ago. And this is why it's never going to happen again. And that's what helps, you know. So it's not that you're horrible or that you're stupid. It's that that problem had existed for years and no one had ever fixed it, right? And it just bit us really hard that day. So we made it so it wouldn't bite again.
Awesome. Yeah, it's a great point. You know, we put all the pressure on ourselves, but other people make mistakes as well.
Exactly.
And problems are an opportunity to innovate and make us stronger, sharper. I love it. Could I give you one more question? Are we all you okay? All right.
I'm great.
You're great. All right, great. How does GM's electric cars compare in efficiency with other electric cars? They're going a little technical with you because you got the masters in electrical engineering and biomedical. They're bringing it a little bit now.
No, it's fantastic. It's fantastic. So on electric vehicles, there are a lot of different ways to measure efficiency. But the way that we most often do it is based upon how far you can drive on a charge, right? And so, and this is also one that's very important to our customers because they want to know how far you can drive on a full charge. You know, I'm really proud to say, you know, we have electric vehicles that easily get 350 miles on a charge.
Nice.
Some of them are pushing 400 miles on one charge, which is super exciting. And when compared to our competitors, we are at the top. You know, when I say, you know, we're always jostling between number one and number two, and it depends on what vehicle segment that you're talking about, whether you're talking about small, medium, or large vehicles. But we're right up there. And what we know for sure is that going forward, particularly, and keep in mind for GM, most of the electric vehicles that we've released to date have not been on that new Ultium architecture. The one I was showing you is the Lego building blocks. So the Ultium architecture is one that allows us to maximize efficiency with the least amount of weight. And I heard one of the students, one of the groups, talk about how they were working on lightweighting their electric vehicles. Well, we work on that all the time. We work on that in the overall vehicle, and we also work on it in the battery with the battery stack, right? And so, you know, that's our focus for future research. And I can tell you certain things I can't reveal appropriately, but the future is very bright.
Awesome. Awesome. I think we have time maybe for one more.
Yeah.
What are the main factors engineers should take into account when developing new technology?
This is great. Okay, so a couple things. Love this. So this goes into, I'm going to talk a little bit about AI and machine learning. Okay, so you've got artificial intelligence, you've got machine learning. In the future of engineering is going to be incorporating, you know, AI and machine learning into a lot of solutions that are created, which is a great thing. It allows us to have smaller, faster innovation loops, which is wonderful. But when not done well, it also opens up the door to innovation loops that aren't actually meeting the targeted need, okay? So it's really important that as you set up any kind of, you know, machine learning kind of algorithm or AI-based solution, that you have a very, very strong data set, that you've done great analytics on that, and that you have people that you're working with that can give different perspectives that need to be considered in that design. So engineering starts with design, okay? Design is critical. And you've got to have the right people in the group to make sure your design isn't going to omit some of your required outcomes. And sometimes that means making sure that it serves all the people it needs to serve, okay? So, you know, I'll give you a quick example. So sometimes you go to the washroom or restroom and you wash your hands and you wave your hand, nothing happens. Like water doesn't come on, the paper doesn't come out, and you're like, what the heck is going on, right? Well, that design was flawed. Why was that design flawed? Oftentimes it's not looking for variations in skin color. Well, why is that? Because the people that designed it didn't have variations in their skin color, right? So they designed it to meet the people that were testing it. But if your design isn't strong enough to have a test develop along with it that's going to make sure it's going to meet your full customer base, then it's not good enough. And so you've got to have the right people engaged. You've got to make a design and design testing that's going to ensure that you're meeting your customer base. And if you happen to be on a group that's not very diverse, go and seek counsel from others so that you can get a design and testing regimen that's actually going to give you the outcome that you want. Really, really, really important from an engineering perspective. And the last thing I'll say, something really important engineers should do: prototype, 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 and prototype, which is what you all were doing today. And you can improve through prototype without spending a whole bunch of money, because you will get pressure to not spend too much money as an engineer.
That is awesome. Prototype, prototype, prototype. You hit the nail on the head. Man, can we just clap it up again for Telva and sharing this time with us? It has been unbelievable. I thought I had a nice slide until I saw your slide. I got to get my slide game up. But that was outstanding. And thank you all to you all students. I mean, you know, 30,000 plus students engaged in this lab at some level. You all built some absolutely wonderful vehicles, and that just demonstrated anything that you put your mind to, you can do it. You can. And we can't wait to see you in some more labs. Let me hand this back over to Monica to talk to you all about next steps. Telva, killed it.
Telva and Milton, amazing, amazing day today. Thank you so much. This has been the largest Engineering Tomorrow event to date. We are so happy to have everybody here live that was able to be here live. For those of you watching the recording, please don't forget to complete your exit tickets. We definitely want to hear your feedback, whether you were live or watching the recording. And don't forget that we have our next special event day on May 24th, which is Bridges. We also have another special event right after that, June 1st, for machine learning. So if you have not signed up yet, please teachers sign up. We'd love to see you and your students. Thank you all for joining us. It has been an amazing day. Thank you, Telva. Thank you, Milton. And thank you to all the ET staff for being here with us and for supporting us throughout this entire day. Thank you so much. Have a great day. We'll see you for the next one, everybody. Bye.
Bye. Awesome.